Hello friends, today I would proceed further and explain as to how the display function related to the circular queue can be designed. The display function that way is a simple function. This is the way that I should be writing the display function. In fact, directly first I would write it in English language. This is our void display function. As I have told you, always you will have to tell as to when the operation is not possible. Think and answer. When is display not possible? If the queue is empty. That is what I am telling. That if in case the queue is empty, if in case the queue is empty, then it means that display is not possible. That is what it means. Display not possible. Otherwise, yes, otherwise it is possible. From where to where will you print? If I will ask you, some of you may feel that, sir, from front to rear we will be printing. Because it is a circular queue, you know, what I would tell you, of course you can use that logic also, it's not that you can't be using. In programming, a certain activity can be done in any number of logics. You can apply whatever logic you want for the display. What I would tell you is this. In a circular queue, I will have count number of elements. In fact, count is kept for that purpose only. If say there are 3 elements in a circular queue, then the count will be 3. Whatever be the number of elements in a circular queue, that would be the count value. So what I would tell you is, I would display count number of elements. Starting from the front, I would display count number of elements. I am telling you, you can employ or you can use different logics for the display purpose. Here I am using this logic that say the count value is 3. It means that there are 3 elements in the circular queue. Say the count value is 5. It means there are 5 elements in the circular queue. So what I am suggesting you is that I would be displaying totally count number of elements starting from the front onwards. That is what is my logic. That is what here I am telling. Display, or in other words, print. Okay, print. Print what? Print count number of elements. Okay, I will print count number of elements starting from where? Starting from the front of the queue. Starting from the front of the queue. That is what I would suggest. This is the closure, this is the closure of it. If you have some other logic for displaying, perfectly fine. I have used the count in order to display, because count can tell me how many elements are there. So count number of elements I will display. Obviously, from where should I start the display? From the front of the queue only I should be starting the display. Anyway, whatever I have written here, I would be converting it into C language code. Watch it. As normal here, I would write void display. Of course, I will create one int I. What next, sir? If the queue is empty, you only know when is the queue considered to be empty. Circular queue, when the count is equal to 0. Correct. That is what I am telling here. If in case the count happens to be equal to 0, then I will tell display not possible. I would tell display not possible. Otherwise I have to display. How many elements should I display? Count number of elements. That is what I am telling. For I equal to 1 till I less than or equal to count I plus plus. Remember, this loop is going to take care of displaying count number of elements. If count is 3, then totally 3 elements will get displayed, because 3 times it is going to loop. If count is 5, then 5 elements it will display, because it is going to loop 5 times. Oh, what to do, sir? Inside I will display printf %d/t. I have told you already y/t. And what to display first? Whatever is there at the front of the queue, that is what I should be displaying. Starting from the front only I should display. Oh, okay, sir. Next I should go to the next element. And in a circular queue, I have told you, if you have to go to the next element, you should tell new value of front is equal to the old value of front plus 1 modulo size. This is what I have told you, so that you can go to the next element and so on. This is the closure, this is the closure, this is the closure of display. This is the way the display function has to be written. Quite a simple function, you know, that if the count is 0, then it means that the display is not possible. Otherwise elements are there, so it is possible. How many elements to print? Count number of elements. So this loop is going to loop count number of times, and I am going to begin printing from the front. After printing the front, to go to the next one, this one, again print it. After that, to go to the next one, this one, again print it, again print it. How many elements? Count number of elements. I hope all of you have been able to understand. But one thing I have to tell you here, which might confuse a few of you. Please understand one thing. Front and rear, you know, you should never modify it while displaying. Front you modify during the deletion operation. Rear you modify during the insertion operation. That is acceptable. For displaying purpose, you know, you should not alter front value. In reality here, you are altering the front value. You are telling f equal to f plus 1, f equal to f plus 1 modulo size you are telling. So what, sir, you may ask. See, this is a bit of logical thinking is required here. You only think queue data structure. Insertion always takes place at the rear end. So during insertion operation, rear value you tell r equal to r plus 1 modulo size, acceptable. During deletion, always whoever is at the front of the queue only will get deleted first, the queue for a cinema ticket. Whoever is at the front only will get deleted. So there you modify front by telling front equal to front plus 1 modulo size. I have no issues. In insertion, modify the rear. In deletion, modify the front. I have no issues, but here we are not doing either insertion or deletion. We are only displaying it, that's all. While displaying, the queue should not get altered. So don't touch front and rear. Because the moment you alter front and rear, you know, then the queue itself, there is a risk of it getting altered. Where am I touching, sir? You may ask. Here you are modifying front. You are touching front and you are modifying it. Logically speaking, never should you modify front and rear while displaying. After all, you are displaying, you are not modifying the queue, you know. You should not touch. Sir, then in this logic, you have only told, sir, starting from the front of the queue, print all the elements, you are only telling. Because you told we used the front F. Now you are telling, no, you should not be using and all that. How do we do it, sir? Then you may ask. Remember, for this purpose, you know, what I will do is that I will create one more variable called F1. One more variable called F1 I will create. Now what is the use of this, sir? You may ask. I will initialize F1 to F. I would be initializing. So the initial value of F1 is the same as F. So later in your program, wherever you have told F, don't use F. I told you don't modify F. But always you can take the value of F in F1 and you can modify F1. You can use F1 for display purpose. So here I can tell F1, after all its value is F only, initial value. Here also, while incrementing, I will not increment f, rather I would be incrementing f1. Oh, what is the use, sir? You may ask. Think logically. The use is that I am not modifying the f and the r of the q. F and r are intact. You may tell, sir, but f1 you are modifying. Sorry, f1 is a temporary variable. F1 is a local variable which I have used only for display purpose. I am not supposed to modify f and r, because in display, if I will modify off the original f, then it will create a lot of trouble. You can try it, you can type the program and try, you would be able to understand it. As a student, you should think like this, that during insertion, rear I will modify. During deletion, front I will modify. During display, neither rear nor front I should modify, because after all it is display operation. But still I have to begin printing from the front only. So a copy of front I will take it in F1, and I will use F1 for the display purpose. My original F value, I won't tamper with it. I won't alter that. That is the concept which you have to understand. I hope I am clear. Please be quick. Alright, I'll now proceed further. The next thing that I should be doing is to write the main function. Main function, if I would write, then the circular queue data structure would be ready. Again I repeat, this style of programming is what we call as structured programming style. Structured programming style, previously also I have told you, if you have a large task, divide it into smaller pieces, focus on each of the smaller piece. In the process, the task would have got completed. That is what we have done even on the circular queue. First we focused only on insert, then we focused only on delete, then we focused only now on display, and now I will be writing the main function. Anyway, pay attention. I would begin by telling hash include stdio.h. Next I will have to create a few global variables. I will create one variable called size with the value 5. I will create front equal to 0, rear equal to -1. I will also create the queue, and I will also create one variable called as count with the initial value 0. These are all the things which I have to declare as global, because only when it is declared as global that all the functions would be able to make use of it. I require all these in insert also, delete also, display also, so I would declare it as global. After that, this is our void insert function. In the insert function, I am not going to write anything because already I have explained. This is our void delete function. Delete function also I have already explained. This is our void display function. Even the display function also, nothing to worry, everything I have already explained. Now it is my duty to write the main function. This is our void main function. In the main function, I will create one variable called as choice. I have told that one variable called as choice I would be creating. After that, I will clear the screen. After clearing the screen, I will first have to give a menu to the programmer. I have already explained it in one of my previous lectures. This is the menu that I will be giving to the programmer. Programmer, press 1 to insert. Like this I am giving him a menu. Similarly, programmer, press 2 to delete. Similarly, programmer, press 3 to display. Similarly, programmer, press 4 to stop. And after all this, I will ask the programmer, enter your choice. Enter your choice, I will tell, and whatever is the choice of the programmer, I will scan it, collect and keep it inside the variable called choice. Now what is there in choice, I really don't know. The choice could contain 1 or 2 or 3 or 4. It depends on whatever the programmer presses on the keyboard. But whatever he presses, that choice will collect it, and accordingly the respective function should get called. That is what next the switch is going to do. No space below, so I am writing it here. That is what this switch is going to do. Switch choice. In case the choice is 1, then it means I have to call the insert function, after which I will have to break. All that break story I have told you. If you will not break, what would happen and all that. Similarly, in case the choice is 2, then I will call the delete function and then break. In case the choice is 3, then I will call the display function and then break. In case the choice is 4 or anything else he presses, I have asked him to press 4 to stop. Somebody might press off 5 or 6. It means that basically he wanted to exit. In which case, I would tell here as default. If you tell case 4 also okay, but a better style of programming is to tell it as default. Means if it is not 1, if it is not 2, if it is not 3, if it is anything else that he has pressed, control comes here, in which case I will tell exit. No need to tell for the last one as break, but tell it anyway. Everywhere you have told, there also tell it off. As I have told you that only once if the menu comes and only once if the operation takes place, certainly it is not something that is acceptable. The menu should keep on coming, operation should keep on happening. If that is the case, then I will have to put a infinite loop. How to put a infinite loop? Correct. While 1. Why this while 1 is an infinite loop, please understand. 1 in programming language stands for true. In C language, 1 means true. True means for this while loop, the condition is always true. So it keeps on looping. 0 is treated as false. Anything other than 0, say 1 is treated as true. So this condition is always true, so it keeps on looping, which is why we call it as infinite loop. If you want, you can use this, or even for loop also you can use. How, sir? Like this, for. No initialization, no condition, no incrementation, nothing. Here normally initialization comes. Here normally condition comes. Here normally incrementation comes. If I will not use anything, it means that that loop will keep on looping only. That is the meaning. So infinite loop, you can get it either by telling while 1 or by telling for semicolon semicolon. This way also you can be getting it. Anyway, that is the beginning of the main. This is the ending of the main. I hope all of you have been able to understand the main function. Okay sir, we understood the main function sir. Really is this program going to reuse the memory locations? Really is this program going to overcome the limitations associated with an ordinary queue? If anybody has an issue regarding that, you can only notice the output. The same program has been typed, no change. Now when I'll compile it, when I'll compile, notice no issues. When I'll execute, first itself I will tell delete by giving the option as say 2, in which case I will get deletion not possible. If I will tell display, I will get display not possible. So I will first tell insert 1, in which case element it will ask 10. Again insert, that is 1, element is 20. Again 1, 30. Again 1, 40. Again 1, 50. You know the size is 5. So only 5 locations are there. Everything is filled. Again if in case I tell 1, and then if I will ask, insertion not possible. Correct, no space, so insertion not possible. Correct it is. So now I will display it by pressing 3, in which case I am getting 10, 20, 30, 40, 50. Correct. Now if I will ask you to delete, it is first in, first out. After all, queue data structure, circular queue only. Circular queue is also queue only after all. So first in, first out means 10 will get deleted. Notice if I will give the option as 2, then element deleted is 10. I can display it for you. Now if I display like this, I will get 20, 30, 40, 50. That is what I would get. Oh, okay. So one vacancy is created, remember. Now again when I will delete it, this time 20 gets deleted. I will display it for you. If I will display it for you, 30, 40, 50 is there. 2 vacancies are there. In an ordinary queue, those vacant locations we were not able to reuse, whereas here we will be able to reuse. How sir? How will you be able to reuse, sir? Notice it, that is the way we have coded the program. Using that modulo, we can be reusing it. Hence, now again I will press 1, in which case it will ask me enter the element. Means it is ready to reuse. I will enter it as 60. Again I will enter 1, in which case it will ask me the element 70. So the 2 vacant locations I have used it off. Again if I will press 1, then it will tell no, insertion not possible. If I will ask you to display, some of you may think that, oh, display means 60, 70 and then 30, 20, 40, 50 will come. That is not the way. Already 2 elements have been deleted. 30 is only at the front. So the output would be 30, 40, 50, 60, 70. That is how the output would be. Notice 30, 40, 50, 60, 70. That is the way the coding has been done, wherein it is in a manner where the elements that are gone. In the vacant locations, the newly added elements will go and sit. Now if I would delete it, say, then obviously first in, first out. Out of all these elements, the first one to get in was 30. So the first one to get deleted is also 30. Again delete if I will tell 40. Again delete 50. Again delete 60. Again delete 70. Now that everything is deleted, again delete. I will get the output as deletion not possible. In simple words, whatever limitation we had in an ordinary queue, we have been able to overcome that limitation in this one. That is the circular queue. I hope all of you have been able to understand it. You can now quickly copy the code as it is on the board. Alright, so I think it is understood, no issues in this. However, I would like to rewrite this program by making use of local variables. Previously, if you recollect, the stack program, I had written it wherein the array s, initially I had it as global, later I made it local. Here also I would like to do it, but this time I would like to not only make this q as local to the main, I would also like to make front, rear, count, everything as local. In other words, these things that are here, these declarations, I will be taking it out, and here I would be putting it. I would be putting it as int front equal to 0, rear equal to -1. I would be putting it as int q of 5. I would be putting it as int count equal to 0. Like this I have made it. Now that everything is local here, certainly the insert function, the delete function, the display function can't make use of the front, rear, count, q, all that they can't make use. Previously it was all global, so everyone could easily, freely make use of it. Now that it is local, if the main passes it as parameter, only then these people can receive the parameter and use it. Main is the owner of these things now. All these things are local to main, main is the owner. If main is ready to pass as parameter, then these people can collect it and use it. Otherwise they can't be doing it. Oh, correct, sir. What to do, sir, you may ask. What to do? Notice, this time, whatever insert I have, this insert function, I would be calling it like this. Not only will I tell insert, I will pass the q, I will pass front, I will pass rear, I will pass count. Here also, for delete also, I will pass q, I will pass front, rear and count. What I would do here is, I would bring in pointers also. What pointers, sir, you may ask. Notice, instead of passing front, rear and all that, I will pass off ampersand front, ampersand rear, ampersand count I can pass. Addresses I will pass. Pass by reference I am using. Here also, I can pass ampersand front, ampersand rear, ampersand count. Some of you may tell, sir, for all this address you are passing, sir, here why are you not telling ampersand q, sir, you may ask. Please understand, q is not an ordinary variable, q is an array. And in one of my previous lectures in strings I have told you, mentioning the array name gives us the base address. When mentioning the name only directly gives us base address, why should I upon that put ampersand? Think, if when our array name was str, what did I tell you? Array name is always going to represent the base address. So as such, this is representing address only. Don't put off ampersand on that. Whereas these are all normal variables. If you want their addresses, then you should use ampersand. Oh, correct, sir. What you are telling is correct. That if I just tell q, it is an array. And array name always gives me address only. Q of 0 will give me the first element, q of 1 next element, q of 2 next element. Only q, it will give me the base address. That is what even I am telling. When q is itself giving base address, why will you tell ampersand q? That you should not do. Whereas, if in case I tell only f, address I will not get, value I will get off. Because f is not an array, f is an ordinary variable. So only f if I tell, address I won't get, value I will get off. But what I want is address. If you want address, then tell ampersand. Similarly, ampersand r. Similarly, ampersand count, like that. I am only teaching you one more style of programming, that's all. It's not that you have to do like this. I am just telling you, if you make it local, then you can actually pass them as parameters like this. Okay, sir. Next what, sir, you may ask. If you will pass them as parameters, naturally you should receive it here. You can't just have insert like this. You have to receive that. Please understand, the first parameter that is coming is q, which I will collect it like this. Int q, like this I will have to collect because it is an array. The second thing that is coming is ampersand f. Remember, whenever address is sent, normal parameters can't collect it. As I have told you, pointers only can collect it. So whenever an address is being sent, pointer only should collect. I can collect it in a pointer called p, in a pointer called q. I can collect it in any pointer. Why to collect it in some pointer? I will collect it in a pointer called f only. I can also tell p, I can also tell q, I can also tell r, my wish. Q I can't use because already q I have used of here. The pointer's name can be anything. Then I can use f only as the pointer's name. Similarly, the address of r that you are sending, I will collect it in a pointer called as r. The count that you are sending, I am collecting it in a pointer called as count. So now understand one thing. Inside this, the body also will change. Previously, f, r and count were all variables previously. Whereas this time, f, r and count are all pointers. So inside, if you will just tell f, what will you get? Please understand, pointer always holds the address. So you can't just tell f, because it will have the address. If you want the data, you should penetrate the pointer. And for penetration, which operator do we make use of? Star operator. So in your previous program here, where all f has come, there all you should tell star f this time. Where all r has come, you should tell star r. Where all count has come, you should tell star count. Why, sir, you may ask? I am telling you, previously f, r and count were ordinary variables. So the moment you used their names, you got their values. Now they are not ordinary variables, they are pointers. So if you just tell f, you will not get data, you will get address. If you want the data, penetrate the pointer using star. I would demonstrate it directly on the display. You would be able to understand it. Similarly here also, whatever you are passing, like this I can collect here also. Int star f, int star r, int star count. Similarly here also, int q like this, and then int star f, int star r, and int star count. Like this only I would write it. So what I have done here is, I have made all this as local. Because it is local, you have to pass them, and if you will pass them, it would be collected, it would be used. While using, you should be careful. We cannot simply use it. We have to ensure that because now f, r and count are all pointers, if you want the data through a pointer, you should penetrate the pointer and use. Long back, that is what I have told you. Anyway, let us see this program as to how it works. Notice this. First, the main program, I have displayed it for your reference. All this front, rear, all this I have made it as local to the main. Remaining all this, press 1 to insert, all that is the same. If you actually look at the switch, here you can see for insert I am passing q, ampersand f, ampersand r, ampersand count. All these, would send the addresses. In fact, q also is the base address only. Don't tell of ampersand q. Arrays, if you mention the name, you will get address only. So all addresses only I am sending here. Okay, sir. Go to the insert body, sir, you may ask. Okay, I will go to the insert body. Notice it. This is only the body of insert. Whatever has been passed, everything has been collected here. But please understand one thing. Whatever in the previous programs you have told if count equal to size, now you can't tell count equal to size, because just count, if you tell, count is a pointer this time. So if you tell only count here, not star count, if you just tell count, count will not give you data, count will give you of address. Address will get compared with the size. If you want data, you should penetrate the pointer. That is what this star is doing, penetrate the pointer. Now what you will get, star count will penetrate count, and what you would be able to get is the data. So in simple words, wherever count is there, wherever R is there, all such places, star R, like that you have to make use of. The point is simple, that the difference between the previous program and this program is, there F, R, count, they were all normal variables in the previous program. So if you tell F, you used to get the data. If you tell R, you used to get the data. If you tell count, you used to get the data. But this time, if you tell only F, only R, only count, if you will tell, data you will not get, addresses you will get off. Because F, R and count are all pointers. Pointers hold addresses. So never should you use F, R, count. If you want the data, you should tell star F, star R, star count. Do it mechanically, it will work. No need to even think about it. If you want, you can copy this function, because I have not written it on the board, you can maybe copy this. Okay. So similarly, even the delete as well. Notice the delete function. This is only our delete function. This is only our delete function. Everything is the same, but as I told you, wherever count previously has come, now star count, star F, star F, star F, like that. This also you can copy, since I have not written it on the board. All right. Next it is the display. Notice in display also everything is the same. The moment you look at display, I think you are now able to completely understand. For F1, don't tell of star F1 and all that. F1 is not a pointer that you will penetrate it and access. F1 after all is a normal variable. So don't tell of star F1 and all that. Wherever F, R count has come, only there. See here F has come. So you should tell star F if you want the data. You can copy this as well. Right. And then the main method, anyway the main method from the board itself you can be copying it. Okay sir, will it work sir? You may ask. 100% it is going to work. Notice it. When I will compile, 3 warnings I am getting. Warning I don't care. However, when I will execute like this, first itself delete. Deletion not possible. Display. Display not possible. So 1, that is insert 10. Again 120. Again 130. Again 140. Again 150. All the locations are filled. Again 1 if I will tell, then it will tell insertion not possible. I will display it by telling 3, in which case I will get the output like this. Now I will delete it by telling 2, 10 gets deleted, again 2, 20 gets deleted. Now I will again insert by telling 1 and 60, again 1 and then 70. Again 1 if I will tell, it will tell no, insertion not possible. Now if I will display it, I would get it like this. And then if I now tell delete, obviously 30 is deleted, next 40, next 50 is deleted, next 60, next 70. All elements are deleted. Again if I will now tell display, if I would tell, then display not possible. When everything is deleted, nothing can be displayed. I hope it is clear that the output is the same, be it the previous program or this program, output is the same, no change in the output. Only in a different style I have written the program, that's all. If you want, you can write the program in the previous style also, this style also. I just have told you that if you make everything as local, then you will have to pass all those as parameters. You have to pass it. And here I have not used pass by value. Rather, here what I have used is pass by address, or in other words, what I have used is pass by reference. That is what I have used. Why have you not used pass by value, sir? Why have you used pass by address, or in other words, pass by reference? Why have you used, sir? You may ask. I will tell you why I have done that. First, quickly copy the main function as it is. I will tell you as to why I have used pass by reference. Why pass by value I have not used, I would be telling you. In fact, while copying, you think and copy. As to why I have used pass by address, why I have not used pass by value in this program, think and copy it. Also, some of you would be concerned, sir, everything you made of local, sir, that size you didn't make it as local, sir, size you have it as global only, sir, still you may tell. Make size also local. What is there in that? I have just kept that one size as global. Make that also local. Declare that int size here and pass here ampersand size, ampersand size, ampersand size. Here collect it. Int star size, int star size, int star size collect. In the body, wherever previously size has come, at all such places, you should tell star size, star size. I think that all of you would be able to do it. Copy the main function, and while copying, think as to why I have not used pass by value in this program. Think and answer. One thing I can tell you, if you use pass by value, program will not work. Oh, is it, sir? 100% it will not work. Simply I have not used pass by reference. There is a purpose. Why I have used pass by reference? You think. If you can't, wait for some more time and I would be able to give you the answer. Please be quick. All right. So I hope the program is clear. In fact, the program became clear long back. This is just another version of coding that I taught you. But coming to this technical question, why didn't I use pass by value? Why did I use pass by reference? Long back, if you recollect, I have told you, pass by value is such a parameter passing technique in which any changes made in the called function will not get reflected back in the calling function. That is what is pass by value, if you recollect. Pass by reference, any change you make in the called function will get reflected back in the calling function. That is only pass by reference. Long back I have clarified it. In pass by value, whatever change you make in the called function will not get reflected back in the calling function. Whereas in pass by reference, any change you make in the called will get reflected back in the calling function. Okay, sir, that we know, sir. Previously in one of the videos you have only told, sir. Why here you are using pass by reference? Tell it. Listen. If in case foolishly I will not pass by reference, I will just tell f r count, assume. Foolishly I will only pass f r and count. In which case, after all, they are all normal variables. So here, no need of pointers to collect it. Just I can collect it like this. Just I can collect it like this. So the point is, if in case I do it like this, the problem, this is only called as pass by value. This is only called pass by value. What did I tell you? In pass by value, you are calling this. So this is the called function. This is the calling function. If you pass by value, any change you make here will not get reflected back in the main function. It will not get reflected back. You only think, in insert, is not my count value going to get changed? Because each time you insert, you will keep incrementing count. Will not my rare value get changed? Because insert is such an operation which will keep on changing the rare value, because insertion always takes place at the rare end. With that being the case, whatever changes occurs here should get reflected back here. No, sir, if it doesn't get reflected, what will happen, sir? Assume 5 elements you will insert. So the count will be 5 in as far as insert is concerned. But say the count value is not reflected back here in the main function, then the count value will be 0 only. Actually, you have inserted 5 elements, you have inserted. Count also you have made it as you have incremented, so the count is 5. But that change doesn't get reflected back in the main. So whatever changes you do here, insert, delete, display, whatever changes you do, your front will be 0 only, your rear will be -1 only, your count will be 0 only always here. That is a meaningless program to write. Please understand, whenever previous program that you copied, all were global. As long as the variables are global variables, no issues. Because global variable changes will keep getting reflected. Everyone can use the global variable. Whatever change somebody makes, all others it will get reflected. That is what was the benefit of global variables. But the moment you make it as local and the moment you pass it as parameter, you should be careful. Whatever you pass as parameter, if it is altered and if the alteration has to get reflected back to you, then make sure that while passing, you are not using pass by value. You are using pass by reference. That is the reason I used pass by reference. If you want, you type the program, pass by value, and see what is going to happen. 100% your program will not be working. I hope I am completely clear with it. The concept is a simple concept. Any changes that are made here should get reflected back here. Otherwise, if it doesn't get reflected back, here with all your efforts you will make the changes, but in as far as main is concerned, front is always 0, rear is always -1, count is always 0, meaningless it is. We want the changes to get reflected back, and if you want the changes to get reflected back, then we have to use pass by reference. That is the reason why I passed all this by reference. I passed this, everything by reference, so that if you make changes to f, r and count, those changes will get reflected back here as well. That is what was the reason for me to use pass by reference in this program. Oh, okay, sir. We understood what you told. We understood, sir. You also told this size I will make it as local, sir. Can I make the size as local? 100%. Make size as local. Who is preventing you? This int size equal to 5, I will make it as local like this. Int size equal to 5. In which case now you should be passing it as parameter. No space here, so I would just tell comma and I would be passing size as the parameter. Again here also I will tell comma, I will be passing size as the parameter. Similarly here also I will tell comma and I will be passing size as the parameter. So I am just passing all that as parameter. I know now some of you would be thinking, sir, what sir, here you told ampersand, ampersand, ampersand. For size you are not telling ampersand at all. Size you are passing by value, you are not passing by reference. Correct. I am passing size by value because I am passing here I have to collect. No space here. So, anyway, all these are by reference. So, I will write back these stars here. And while collecting, I will collect it as just int size. Here also, no space. So, anyway, I will just collect it as int size. Here also, I will just collect it as int size. You may tell, sir, you are confusing us, sir. Why are you not passing size by reference, sir? Why are you passing size by value, sir? You may ask. What did I tell you? That if at all changes are going to happen to some variables, and if those changed values should get reflected back, then only use pass by reference. You only think and answer. In insert, anywhere, am I changing the size value? Am I telling plus plus size? Or am I telling minus minus size? Anywhere am I changing the size value? No. In delete, you only check the body and tell me. Anywhere am I changing the size value? Remember, I am only using the size value. I am not changing it. When I tell r equal to r plus 1 modulo size, I am only using size. Where am I changing size? Where have I told plus plus size, minus minus size? Where have I told? When you are not at all altering the size value, then what is the fun in passing it by reference? Of course, you can pass size also by reference. It's not that you can't pass it by reference. But your team leader, your project manager will feel that you are such a fool who doesn't know what to pass by value and what to pass by reference. Please understand one thing. Such things which change, and if the change has to get reflected back, then use pass by reference. Such things whose values won't change, then you can use pass by value. Size is 5 only throughout the program. Size is 5 only. Neither am I incrementing the size nor am I decrementing the size. Then pass it by value only. Whereas front, rear, count, the Q array, everything the value would change. Front, rear initially will be 0, minus 1. Later rear will keep on changing. Front will keep on changing. Count, as you insert, it will get incremented. As you delete, it will get decremented. With that being the case, naturally you will have to pass front, rear, count by reference, because those values will get changed in these functions, and the changed value should get reflected back. So we will pass it by reference. Whereas size value is only used by these functions. They will not change the value of size. So something which is going to be only used, which won't get changed, naturally you can use pass by value. This is the story that I wanted you to understand through this example. In the interviews, they will ask, is pass by value good or is pass by reference good? You should not tell pass by reference is good or pass by value is good. You should not tell like that. You should give a more mature answer. You should tell, sir, be it pass by value or be it pass by reference, they are parameter passing techniques. If in programming I want to pass a value, which value is going to be only used, but it won't get altered, in such cases I will use pass by value. Example, size. If in case I want to pass such parameters whose values will get altered, and that altered new value should get reflected back to me, in such cases I will be using pass by reference, or in other words pass by address I would be using. That is what should be your mature answer. I hope it is clear. Now let us execute it and check if it's going to work or not. Pay attention. As you can see, even the size, I have made it as local. It is inside the main function. And I am passing size as just size, means pass by value it is. If I will go to the insert function, you can see that I have collected it in a variable called as size only. Actually, while collecting, you can collect it in a variable called temp, in a variable called x you can collect. Why? I will collect it in size only. Don't ask me, sir, why are you not telling star size here? Why will I tell star size? Size is not a pointer that I should penetrate it to get the value. It's not a pointer. It's an ordinary variable size. So to get the value, if I just mention the name, it is sufficient. Whereas count is a pointer. And hence, if you want the value, you should penetrate the pointer. That is why star count I have told. Size, as it is I have used, no change. Similarly, if you notice the delete also, size I have included, and wherever size I have used it. That's it. I am not altering size anywhere. I am not modifying it anywhere. Similarly, if you notice the display as well. I hope it is clear. Now if I will compile, as you can see, warnings are there which I don't care. Next, if I'll execute it, first only I will tell display, not possible, delete, not possible. So insert 110, next 120, next 130, next 140, next 150, next 1, in which case it will tell insertion not possible. So I will display it. After displaying, like this I will get. Anyway, you can delete and all that and cross check. That should not be an issue. I hope all of you have been able to understand this. If you would like to copy the program on the board, you can copy and also write your own explanation as to when you should use pass by value, when you should use pass by reference, on which type of variables should we use pass by value, on which type of variables should we use pass by reference. I hope this session has given you more insight into the concept of pass by value and pass by reference. In fact, our previous program, stack, ordinary queue, all that you try writing it like this. It would make you a better programmer. Quickly you can be copying this. All right. So I hope all of you have been able to understand the circular queue data structure and how it helps us to overcome the limitation associated with an ordinary queue data structure also you have been able to understand. I would like to end this session by giving you one table which you have to remember as a student, interested in the placement activities. Just this one table I am giving. This is the table which is going to tell you the conditions. This is the empty condition. This is the full condition. This is the data structure. 3 data structures we have learnt. One is the stack data structure, one is the queue data structure, another one the circular queue data structure. The circular queue data structure. You know, stack is said to be empty when top is equal to minus 1. In fact, it is said to be full when top is equal to size minus 1. Similarly, queue is said to be empty if rear is equal to minus 1 or if front is greater than rear. All that pictorially I have represented previously. It is said to be full if rear is equal to size minus 1. It is said to be full. Similarly, circular queue is said to be empty if count is equal to 0. Circular queue is said to be full if in case count is equal to size. That is when it is said to be full. I hope all of you have been able to recollect and understand this. We would require this sometimes, in the multiple choice questions in the first round of the interview also, in the first round of the selection process also, they may ask such things. I hope by and large the discussion is completely clear. No confusion in the 3 data structures that you have learned. Long back I have told you that data structure means 2 qualities. First quality is that it should be able to hold the data. Second quality is that it exhibits some behavior, some nature. Stack, it holds data, plus the nature that it exhibits is last in, first out, or first in, last out. Queue, that also holds data and its nature is first in, first out, or last in, last out, without reusability. That is what is ordinary queue. Circular queue also, it can hold data. That is the first criteria. Second one, that is also first in, first out, or last in, last out, with reusability. That is what is its behavior. Like this, how many more data structures we have, what are all its behaviors is what we have to learn. But one thing I can tell you, be it any data structure, be it queue, stack, circular queue, singly linked list, doubly linked list, trees, let it be any data structure. One thing that I can tell you is that all data structures hold data. What they vary is in their behavior. At least 3 behaviors of stacks, ordinary queue and circular queue you have been able to notice. I hope it is completely clear. Thank you very much.